Okay, so I'm going to be doing geometric and arithmetic sequences. So for starters, a sequence is an ordered list of numbers that follows a particular pattern each time. So for example, if I wrote down the numbers, my pen. If I wrote down the numbers 5, 7, 9 and 11, that pattern there would be a difference of 2 each time. And that difference is called the common difference, which we denote by the letter D. So D is the common difference, and in this case that would be 2. With these listed numbers here, we can denote them we can give them values. So for example, if we can call this one U1, U2, U3, U4, and then it will just go on, etc, etc. With most arithmetic sequences, they'll ask you to find the nth term. So let's say in this context that the nth term, they want you to find the 9th term of this geometric sequence. So let's just record this here. They want to find the 9th term of this geometric sequence. We use the formula, let's see, formula UN equals U1 plus n minus 1d. UN is the term we're looking for, in this case the 9th term. U1 is the first term, in this case it's 5. N is again, it's 9, that's the number of terms. And D is common difference, which we've already calculated as being 2, since there's a difference of 2 between each one of these numbers. So to find out the 9th term, we would do 9 equals the first term, which is 5, plus brackets the number of terms, which is going to be 9. Then we do minus 1, and then we do the common difference, which is 2. So that would be 8, so that's 8 times 2, which is 16. So therefore 9 equals 21. You could do it the other way as well. If you wanted to continually go up in numbers, you could go 13, then that'd be 15, and then etc, etc until you get 21. But this is just a shorthand version of how to do it. But most of the time, it would not be this simple. This is quite a simplified version. Normally, you'd have to either find the common difference yourself, and they'll often throw questions in where the numbers are not consecutive. So let's do some examples of that. Okay, so for this question, we have not got 2 consecutive terms, so we can't use the same trick we used before to find the common difference. Here we have U1, which is the first term, which is 5, and we have U4, which is 17. As you can see, the difference between these two is 3. So we can add 3 lots onto the common difference and use that to generate an algebraic equation to find out the common difference. So we can write this as 3D, since there's 3 spaces, common difference of 3 equals 17 minus 5. So that would get us 3D equals 12, and then we move the 3 over there to get D is equal to 4, and that is our common difference right there. Okay, let's consider the next equation here, which is an arithmetic sequence again. For this question, it asks us to find the nth term. We can calculate the common difference real easily. Yeah, wait, what is that? That's a 17, mind you. Sorry, my handwriting's a bit dodgy, I got confused there. So the common difference easily, we can denote that as 6, and U1 is equal to 5. So to find n, we have to write out the formula. What is it again? It is UN equals U1 plus n minus 1 D. So that's the formula there. We don't know what UN is, so that's what we're trying to find out. So we do UN, which is 5, which we do know, plus n, which we still do not know, minus 1 6. And then we have to do a bit of factorization here, I guess. So we have to times the n by the 6 and the minus 1 by the 6 as well. So that would get us UN is equal to 5 plus 6n minus 6. If we move the 5 over there, that 5 will add on to the minus 6, resulting in minus 1. So therefore we'll have UN is equal to 6n minus 1, and that is our thing there. That is what we are looking for to find the nth term of the sequence. We can then check if our answer is correct by matching it up with this over here. So we have 6 times 1, because this is the first term. 6 times 1 is 6, minus 1 is 5, that's correct. Second time, 6 times 2 is 12, minus the 1 is 11, so that one is also correct. Finally, 6 times 3 is 18, minus the 1, which is 17, etc, etc. So we know that this is indeed correct. Okay, so for part B over here, it asks us to find the 200th term of this sequence, which is easy. We just take everything and log it into here over here. So for the 200th term, so that will be U200 equals 6, so that's the nth over here, brackets 200 minus 1. So that would be U200 would equal 6 times 200, which is 1200 minus 1. That would be 1999. Okay, so for the final part of this question here, it asked us if number 623 is part of the sequence or not. If when we do this, it is a whole number, it's an integer, it will be part of the sequence. So let's go ahead and see this. So we take the 623 and put it on the left side of the equation. So let's say if we write 623 and we write that to write that equal to 6n minus 1, so that's the nth term we found out up here. We have to add 1 to either side to get rid of this pesky 1 over here. So that would equal 624 equals simply 6n. And then we divide these both by 6, and that will result in, give me a sec, so it's, what is it, 624 is it? Yep, 624. 624 divided by 6, and that would equal 184. And since 184 is a whole number, it is part of the sequence. Okay, I don't know why I said 184, it's 104. My bad, I don't even know how I got that wrong. It says 104 on my calculator display. I'm just being an idiot, whatever. Okay, so this question here is a bit more complicated since we don't have the common difference or the first value of this arithmetic sequence. So to do this, let's just quickly write U2 equals 10 and U6 equals minus 14. Since in this question we have the second term, which is 10, and the sixth term, which is minus 14. So using the formula up here, we can write this. We can write each one of these ones separately. So we can do the second term, which is 10, UN 10, which equals the first term, which we do not know as of yet, plus n, which is the second term, which is going to be 2 minus 1, and then d. And then we can do the same thing to U6, so that would be minus 14 equals U1 plus 6 minus 1, and then d. We can then simplify these ones a bit easier, so that's 10 equals U1 plus 1d, because 2 minus 1 is 1, 1 times d is 1d, so there we go. And then we can do minus 14 equals U1, and then this time it will be 5d to 6, 6 minus 1 equals 5, 5 times d equals 5d, so there we go, we have 5d. Now this is looking a lot like a simultaneous equation, so we can treat it as a simultaneous equation. So we can do, so since these, so we can do, we put a minus over here, so that'd be 10, what is it? Is it minus? Is it? Yeah, sorry. 10 minus 14, so that would give you 24. 24 equals, the U1s will cancel each other out, which is great. We don't want those anyway, they suck. And then we have the 1d minus the 5d, so that will be minus 4d. So that will be d equals minus 6. And that is how we do that. So it's a bit more tricky, a bit more difficult, but it's still not too hard. The hardest bit is just getting to the simultaneous equation section here. Okay, now it wants us to find the first term of the sequence, and this is still relatively straightforward to do. So what you do is that you take the formula here. So let's just take the first one since there's no negatives involved, it's a bit more easier. So we're going to write it 10 equals U1, what is it, U1 plus 1d. Well, we know what d is already, so we're just going to substitute the minus 6 into d. So let's write 10 equals U1 plus, well, well, what would we do? Plus 1 minus 6. Alright. So we can just expand the brackets again, so that would just be minus 6 actually, so that would just be 10. 10 is this, yeah, 10 equals u1, u1 minus 6. And then we can move this over, and we can have u1, we can move the 6 over here, that'd be 16, so therefore u1 would equal 16, and that's the first term in the sequence, and that's it done. Alright, so this question here wants us to calculate the 12th term. Since we've found out the first term and the common difference all throughout this time, this should be relatively straightforward to do. So we do u12 is equal to 16, which 16 is the first term as we just calculated out previously, plus, what am I doing? Plus 12 minus 1, which would just be 11, minus the 6, which is the common difference. So therefore u12 equals 16 minus 66. And then u12 equals, what's that, minus 50? Minus 50. Okay, so finally we're going to be doing the sum. Oh, the formula for the sum of is, oh dear, my camera shook, oh dear. Sn is equal to n, what am I doing? N over 2, brackets 2 times the first plus n minus 1 d close brackets. So it's nothing really too complicated. Sn stands for the number of terms. In this case, we want to do 26. I forgot to mention that, so I'm a dumbass. So we write S26 equals 26 divided by 2. We can do it at the 13, whatever. Brackets 2 times the first term, which we've already calculated on this other sheet of paper, as, what is it? I can't even see it, I'm blind. Oh, as 16. So 2 times 16 plus the number of terms, which is 26. Minus 1, and d, which is, d was, how much? D was minus 6. Okay, let's calculate this stuff. I know I'm gonna mess up, let's do it though. So I went ahead and did the rest, so that would equal to, so the 26th term would be minus 1,534. You'd often get questions like this, where you don't have two consecutives, so you have to work it out using simultaneous, and then you have to go on to other things, and then, yeah. Now let's move on to geometric sequences. They're different to arithmetic sequences in the fact that they, the difference between them is either multiplied or divided. So, yep, 5, 15, 45. So, what am I doing? Yeah. Let's say this is a very basic geometric sequence. Here, the common ratio, we call it common ratio this time, will be 3. And the way we can calculate this is if that we have two consecutive things, positions, whatever. Then we take the 15 and divide it by 5, and that will be 3. So therefore, the common ratio would also be 3, and we denote common ratio with r. So it's pretty straightforward. It's not too difficult. It's certainly a lot more easy to find than an arithmetic sequence anyway, in my opinion. So whatever. Again, we denote it U1, U2, U3, same difference, same thing, sorry. But the formula this time is UN is equal to the first term, brackets, the common ratio, to the power n minus 1. Okay, so for this geometric sequence, it's asking us to find the nth term. First of all, let's find U1, and that's really simple. U1 is simply 3, and the common ratio is 6 divided by 3, so the common ratio is therefore 2. We have to write this in terms of the formula, which is what I gave over here. So that would simply be UN equals 3, brackets 2, n minus 1, and that's literally it. Very straightforward. Okay, so I went and found an example of a question on a past paper. It says a geometric sequence has the sequence 2, k, and 28, and it asked us to find k. Well, we know that if we divide k by 7, it would equal 28 divided by k. So let's just write that down now. So if we have k over 7, that would equal 28 over k. And with this we can cross multiply, so we can multiply with that by that and that by that. Let's see, so that's 7 times 28, 7 times 28, which would give us 196, and that would give us k squared. So that would give us k squared equals 196. And to get k, we'd have to square root both of these. So we square root the k and square root 196. So k would be equal to the square root of 196, and that would be 14. That would either be plus or minus 14. Let's just say plus. It more than likely will be. The second question is find the common ratio, which is really easy. So r is just 14 divided by 7, which is 2, or you can do 28 divided by 14, which is also 2. So not too difficult there. Okay, so next we're asked to find the sum of the first 14 terms in the sequence. Like arithmetic, we have a formula to calculate the sum of for geometric. It's Sn, which is number of terms, so in this case it would be 14, equals the first term, brackets, common ratio to the power of terms, minus 1 over r over 1. R minus 1. It's not a very complicated formula, so just inputting it real quick. 7, 14 would equal 7, brackets to the power, 2 to the power of 14, minus 1 over 2 over 1, getting the calculator out real quick. So the answer would be, in the end, 114,681. So here it says that the second term is minus 6 and the fifth term is 162. But just like arithmetic sequence, we can make this into a simultaneous equation rather easily. So we just have to plug it into the formula, which is un equals u1 r to the power of n minus 1. So that would give us for u5, that would give us 162 is equal to u1, which we do not know yet, r to the power of 5, so this is the fifth term, minus 1, so that would give us 4. Again, we have with u2, minus 6 equals u1 to r to the power of 1, since it's the second term, so that would be n, that would be 2 minus 1, so therefore we have the 1 over there. We can do simultaneous now, this will be divide, so 162 divided by minus 6, let me just quickly do this over here in the calculator. 162 divided by was it minus 6 equals minus 27. These two will cancel each other out, so we don't need those. And since when you have base and then exponentials, you just take away 4 minus 1, so that will be 3. So then you'd have to do minus 27 to the power of third, and that would be equal to minus 3. Okay, so now it wants us to find the first term. Ignore this, I made a mistake previously, whatever. So you take one of the formulas here and you plug stuff in. So let's take the bottom one, so that would be minus 6 equals the first term, minus 3, 1. So then you just, to open up the brackets, you divide it by 3, divide that by 3, divide that by minus 3, I should say. And simply that would give you u1 equals 2.